Yeah, it's in physics. Yeah, walk and talk physics. Alright, I probably won't make a habit of this. Anyway, sort of thinking about the light wavelength, photon wavelength thing. And, yeah, I'm pretty certain that's another thing the physicists have gotten wrong in terms of thinking about waves. Oh, rain. It really doesn't look like rain. Better not keep doing that. Yeah, you know, because they talk about light in this manner that makes it seem like light is complicated. You know, like it's a stream of a, you know, has an electrical component and a magnetic component, and you know, all this stuff. And yeah, I don't think it has any of that stuff. But anyway, you know, you really can't play around with photons, so you never know how many photons a photon really is. But it's just there's so many curiosities about just how we move and how light moves in terms of, you know, measuring distances and velocity. I mean, somebody could say I'm walking a certain speed because I get from one place to another in a certain amount of time. But in that time, my body is moving up and down and sideways a little too, and so it's the actual pieces of the matter don't move at those speeds because they move, you know, they do a lot more directional movement. And so we have these numbers that really aren't a reflection of actual velocity in terms of what the center of gravity might be doing, or more important, you know, parts are doing. And yeah, so that's just a curiosity running through my head. And light doesn't have that problem, but light has this wavelength component, you know, this distance between the clumps that we call the photon. And this is essentially defines energy. And you know, I think it's just that simple. A clump is a clump. And what really is causing nuance is the reaction, again, of the electrons. The electrons react differently when you hit them with a different stream. So it's almost like the first rock you throw disorients the guy. You know, the second rock you throw makes him turn his head. And the third rock you throw knocks him out. It's that kind of, you know, it takes more than one hit on an electron to create maybe a reaction like absorption. And so if the two hits come, but the third hit is too long, it's too late, then, you know, it's you know, the orbit of the electron and such, you've lost your opportunity because the imbalance has been corrected for, in the sense that the orbit's passed for the first hit, and so the new hit can be absorbed if it was only a second hit. So unless you do the sequence in the proper amount of speed, the electron will react as if you're not hitting it with something that fast. That kind of thing. Yeah, electrons are just very filterish. They're picky. And it's their pickiness that people are misinterpreting for wave functions. There's no wave functions in the energy. The wave function gets created by the nuances of the electron and its association, of course, often with nucleuses and atoms. Anyway, I'll be back. It is raining, which is sort of obnoxious. Anyway, till next time. I'm back. Yeah. So again, another one of these subjects is sort of interesting. Is you know, how light hits our eye. You know, and how our eye moves with things, objects. But this very complex process of recognizing photons, and but it's the mass of them that's really the secret, right? I mean, each one of these objects is spilling, you know, zillions of photons. I mean, you know, very big number, billions anyway, right? billions of photons from every square inch of surface, flying out, and then just a tiny number, reach the atoms inside our eyes, not just the chemicals, but the compounds. But the actual interaction takes place with the atoms, the electrons, and the electrons move, do this kind of electrical thing and create chemical chain reactions, if not directly into neurological chain reactions. Very just to think about how much error there is allowed to be, like how much your eye has to vibrate or something for the signal to get lost. And not lost because it's moving too fast, but lost in the sense that the frequency of the light is no longer correct, and it's not hitting the same place anymore, and there's no continuity in the image. But our brain does compensate for that, so it's a little hard to go by just human eyesight, because our brain just fills it in. It just kind of creates its own ghosting effect, to compensate for the lack of information it's receiving, perhaps. But anyway, the response time of the eye, there is such a thing, and people no doubt have measured it. But each chemical probably has a different response quotient, just like each chemical, each compound, each element has a signature light color frequency of light it'll produce, or photon it'll produce. Certainly I suspect there's some that produce X-rays and other kinds of photons besides visible light. But electrons do seem to have a friendliness towards the light spectrum. It does seem to be the dominant photon in the universe, but that's just because of mostly our familiarity with it. The fact that the things around us are sensitive to it. Again, if gravity is actually photons of some non-frequency, wavelength-less photons, they could be streaming through us right now, thick as molasses, and we'd have no way of knowing if no mechanism is irritable to them, in the sense that the photons don't interact with the electrons in any discernible absorption kind of way. The effect could be quite benign. But as with gravity, obviously the effect isn't benign. It is as if we're having something quite heavy poured on us, poured through us, and that's the key word, through. We don't absorb it, it just changes us, changes the disposition of our mass and points it in a direction. The mass of photons, the school of the fish. So anyway, go the other way. I don't get poison ivy, but I was feeling kind of itchy today, so it got me a little paranoid. Not that this path is any better. Oh, pricker bushes everywhere. Quite challenging. Anyway. Yeah, rest stop. Yeah. So, an empty pond, an empty chair, lonely, isolated. So much. Oh, I keep forgetting to cover my soil. My soil. My soul. Yeah, it's not too bad. It's damp. So of course I walk away without putting the cover on. Yeah. My style lately. So yeah, everything's going fallish here. Ugh. Yep. Hey, cat. Meow. Yeah. Gray photons. Lots of gray photons. Yeah. Yeah. Oh, little fanglet. Anyway, bird's nest. Guess I could say it was something interesting. Pterodactyl. So anyway, like physicists, I'll make something up. Anyway, till next time. And such, and so forth and whatnot. There's one little grass flower. Yeah, I got some, still got something here. Sunflower. Sunflower's pretty funny. Very late for a sunflower. So, anyway. Yeah, till, maybe I'll add something. Yeah, maybe. Alright, add on. Yeah, I might as well do some comments. I only have 22 minutes left of the camera, so we'll see how far we get. So anyway, this Douglas Conway guy actually agrees with me about some stuff, and is talking about maybe some way to judge absolute speed by 6-directional light shooting out of something, blah blah blah. The real problem is that, you know, it's not that light doesn't have a consistent speed, is that there's no way to time the light. So, you know, it's having clock starting when the light is actually produced, and having a clock stop when the light is received somewhere, and it's the clocks of on the producer and on the receiver that are the problem, in terms of there's no way to synchronize the clocks. So that's where you sort of get into trouble. So anyway, so this stupid Rick guy, let's see what he says here. Hey, and Mendham, tell us how a prism works if frequency is the product of the number of photons on the exact same trajectory. Alright, so there's this, you know, basic argument. Like I said, I'm tending toward this perception. Like I said, this isn't one of the things in my actual platform, these things, so these aren't necessarily points I want to argue. But I think it's necessary to an understanding, you know, a more complete understanding of what's taking place. Okay, I mean, photons interact with electrons. That's what they do. Okay, so that's the thing to understand, is that a photon does not go into matter without interacting with electrons. Photons don't just bounce off of something. Okay, they actually go into something and are readmitted, or they're absorbed and something else is emitted, and then some other atom admits it. So the thing to understand is this is quantum, let's see what's the right word to use, quantum electrodynamics. This is what happens to photons. Photons interact with electrons. So what's happening in a prism is that light of different frequencies, which means you know, it's coming in at different wavelengths, and it's coming at an angle of incident into you know, a material like a prism, and so it's hitting the atoms, which are all in a prism or in glass or in some. The structure is very rigid in terms of there's a specific way that the atoms line up, depending on the thickness of the material. So obviously with a prism, a key function of the prism is the triangle, which basically is saying, in a sense, that these atoms will be lined up a little bit different for each layer of the prism because of the atomic pressure. See, a glass is, you know, most glasses are technically, they're liquids. You know, they're not solids. And this is one of the features of glass. This is why it's not only transparent, but this is why glass does this lensing thing and does all these other things, is because glass has this unique feature, likely, that its atoms can rotate, you know, based on the depth of this configuration. So as this gets wider, it means these surface atoms are slightly tilted. for each. So there's a little more tilt, a little more tilt, a little more tilt, a little more tilt. So each atom's going to have a different reaction to the light that comes in. It's going to bend it, it's going to release it at a different angle. So because of the tilt, you might be hitting a different electron. So to understand that electrons are in packages, in atoms usually, of different size electrons, and which electron you hit will decide what angle you'll likely go out at. So let's say if you hit the big electron, you'd go out at a 30-degree angle. You hit the inside electron, you go at a 50-degree angle. So each one's going to create a different angle of refraction, and I think that's sort of what we're seeing happen there. So obviously, it's when what needs to sort of be understood by my theory, okay, is that photons have to be in pairs to be acknowledged as a photon. A photon can't be recognized unless it's with another photon to establish its wavelength. So, but anyway, they come in as a packet of photon. So when you say photon, you're probably saying two photons, unless they're gravitons, which are probably photons without a wavelength. But I went through some of this before, but there's no point. Well, the key thing to understand is each electron, depending on its size, will have a different speed with which it spirals. Okay, so it has a beginning and an ending, let's say, and the key factor is the time it takes to go from here to, say, half the cycle. So that's an important time feature, is this half cycle. And the idea would be is that a photon would have to have a wavelength sufficient where there would be two impacts. So the first photon hits the electron. Well, this is the actual electron here. It hits it, and then it moves through part of the cycle, and then the second one hits before it gets all the way past the halfway point, let's say. And if that happens, then the electron releases the commensurate same energy in a new direction. Some sort of mechanism like that. So obviously the wider the wavelength wouldn't work on some photons, because the electron would go all the way around to the other side, and it might just release the photon as it received it, or as in a different wavelength even. But I mean, it's not going to have the same effect, I guess is what I'm saying. So depending on what electron you hit will dictate what kind of frequency light it's susceptible to. The other thing to understand is these electrons could possibly be in some sort of double helix configuration where they're spinning, and it could be just how you hit the electron, in terms of the photon comes in, disrupts one branch of the helix, and if the frequency is narrower than the depth of the if the wavelength is narrower or longer than the depth of the helix, then the photon will just go through. If it's narrower, I mean, what I'm saying, if it's wider, but if it's narrower, then it will cause the helix to shoot a new photon, shoot the branch out. So it'll just replace the new double with a double released, but at specific angles. So there's lots of ways you can explain the mechanism. So I'm just saying, if you want an explanation, it's something like that. Is that enough? Anyway, also please elaborate on the process by which PRISM decides, which photon belongs to which frequency. Well, you're joking about the decides, but I mean, the electrons do decide the circumstance of which electron you hit. And again, you're the one talking as if matter is matter. Matter is not matter. Matter is energy. Matter is electrons. And it's an interaction between photons and electrons. And as we know from quantum mechanics, is those interactions can have quite a bit of nuance to them. So it's certainly within the realm of reasonable to say something like electrons are like filters, and they only react to certain specific kinds of interactions. You have to rub them a certain way for them to do a certain thing. Alright, it's not clear from the... Okay, so here's this stupid Kepler crap again. It's not clear from the wiki article, but when deriving Kepler's laws, it's common to use a zigzag vector representation for the velocity of the orbiting body. Again, the subject of the video was the timing issue. The fact that the connection between velocity and time dilation. And I was really making just the argument that yes, this gravitational velocity is the same as any other velocity. So I mean, the acceleration you get from gravity creates a velocity in you in one direction, and then you have this other velocity in some other direction that keeps you in orbit. And it needs to be considered exactly how much wobble there are in these velocities. And the more important wobble, the one I was making the bigger point about, was things in the stronger gravitational field that are not free falling, that are impacting already compacted matter, likely do have a substantial frequency vibration. They are likely have an increased velocity, okay, for any lateral movement, because that lateral movement will involve a lot of movement inside the movement. And that you can't say it's moving 60 miles an hour when it's doing this, okay, then it's moving 120 miles an hour. And that's sort of important. And that's lost on you imbeciles. So anyway, so the article said nothing about that. It had nothing to do with relativity. It even said something about this has nothing to do with relativity right in the wiki article. So I don't know why you keep trying to defend what he posted as being relevant. It wasn't relevant. The deviation for a photon's momentum that I included is from special relativity. I suppose you could say special relativity and the additional E equals EFE combination from Planck-Einstein. Well, and the H is just Planck's constant times frequency, so basically it's just E equals F. I mean, the constants are just there to create some regularity in numbers. So I mean, I almost wish they wouldn't put the constants in, because they just kind of mess up the math. I mean, it's just E equals F. And obviously, again, I'll make the point that yes, the energy of your machine gun is going to be dependent on how many bullets it shoots. If all the bullets come out at the same exact speed, the only thing you can adjust is how many bullets come out in a certain amount of time, and that's the definition of energy. Photons are energy. Jeez, space child. Oh, so rude. I'm going to have to block him again. You are currently not a new, whatever this Ramugen, or some kind of old unattractive Will Hunting. It's easy to say you're a genius. It's a little hard to actually be one. Yeah, well, this is just ad hominem crap again. You're not arguing what I'm saying. You're just arguing crap. Okay, the Nobel Prize winners this year were, and they got their prize for what? Invisible underwear. Again, you're not counter-arguing. What I've done is provided two substantial arguments reclamating the photonic pressure theory of gravity from the two major complaints about it. I mean, there's a third complaint, like what if the moon is between the sun and the earth, wouldn't the moon be blocking, blah blah blah. No, because as pointed out, these rays, this gravity photon isn't absorbed. It passes through the body. It only changes the body's internal momentum. But anyway, so there's no argument here. You're just wasting my fucking time. Wasting anybody's time. That's all a lot of you people are, is a waste of time. Are you familiar with the photoelectric effect? Question mark. I mean, it's just amazing bullshit. Yeah, guess what? I was soldering photoresistors into circuit boards in 1976. So, I mean, they're one of my favorite toys. Those in ultrasonic transducers. Love those things. Anyway. This is the work that Einstein won the Nobel Prize for. Well, it doesn't really matter. Shining photons on metal can cause the metal to emit an electron. That's right. And it's not very efficient, though, is it? And that's the key point here, right? It doesn't happen with every photon you shine. Doesn't create an electron. Doesn't energize an electron. It doesn't even matter if it is intense enough light. But again, clearly, you know, even if you were to say that you know, what's clear, okay, the evidence demonstrates, is that even if you have this wave light thing, clearly the electrons are the thing doing the filtering. The electron is saying, that's not hitting me the right way. You have to hit me harder. You have to hit me with more. And I just think it's perfectly logical to understand why red light, you could shine it on metal all day long and it'll do nothing, and then if you hit it with blue light, you know, you'll release an electron, or you'll energize one to a new orbit and essentially do the same thing. So again, here's red light at whatever 600 nanometers, I don't know, and this is like blue light is like what, 400. I have to remember this stuff. It's like half, I thought. So that can't be right. Well, maybe it's 800 for red. I don't think so. Well, anyway, I have to write all this stuff down. You know, I have to really get a notebook and start writing down all this stupid shit that I really don't want to do. But anyway, let's just say it's twice as fast as red. Blue is twice as fast as red. So that's sort of the point, that the electron, like I said, again, you could just illustrate by this point that it has a cycle, and that half that cycle, there's a big difference between hitting it twice while it's going on this side, and then hitting it once and having the other impact happen after this impact has already moved, you know, after this part that was impacted has already moved to this side, which means it's already being half adjusted for, let's say. So it's like this, it's like a vibration model, you know, and you get to a certain pitch and the glass doesn't break. But you go up to a high enough pitch and the glass breaks. Well, you can understand it's the same kind of effect, right? That the vibration has to be the right vibration for the glass to break. And it's just another vibration argument. You've got to hit it with enough stuff while it's vulnerable to create the fissures or the cracks. And the electron's just doing the same thing representationally. It's just saying, you have to hit me the right way for me to become a liberated electron. Duh. It's so obnoxious. Alright, so anyway, so draft science. No. It's demonstrated that electrons act as a filter and only absorb or emit photons at specific frequencies. So then he does this little thing here. You can phrase it that way if you want. See, isn't that great? Yeah, well, this phrasing's, the whole point is this phrasing's really important. It's really important to say, yeah, electrons are filtering for certain frequencies. And I think that's demonstrated in the whole fact that there is a color spectrum in terms of, you know, spectrography, and the whole idea that you can find the signature of chemical compounds based on the colors they emit, their electrons emit, you know, the light emitted. So you can have a bunch of cosmic rays or X-rays go in, and the energy will bounce around a bit, and you can have a bunch of visible colored light come out based on the electrons producing it. So the electrons are essentially converting X-rays into visible light. And you see that in a lot of cosmological events. The critical point is that the energy of a photon is dependent on frequency. Well, again, who was arguing something else? I'm not arguing anything else. I'm arguing that, yes, all the photons are the same, and the difference between a radio wave and an X-ray is that in a specific amount of time, you're going to get hit with a lot more X-rays than you are going to get hit with radio waves. That's the argument. That they're going to come at a higher frequency and they're going to break your glass. It also admits the photon with energy E, again with the HF equals F. You can use the frequency to determine where it resides in the electromagnetic spectrum. you don't use the net number of photons. Again, you can do it your way. What I'm saying is that's incorrect. You can use the net number of photons if you just acknowledge that photons must come in pairs to be recognized as having a frequency, period, or a wavelength. And just establishing that minimum rule. And again, I think there's good evidence that they are created in pairs, so this sort of does make sense. I mean, obviously we can't see photons, so we can't see that there's two of the things we're calling a one. And obviously we can't see them with it's just a one, because the only matter that can detect that gravity is matter itself. It has to be in the form of an atomic structure to sense gravitons, let's call them. So whether they're being sensed by the proton or the neutron, or a combination of the electron, the proton, the neutron, doesn't really matter, but they're, obviously they're capable of orienting atoms and orienting the electrons. The bottom line is they're capable of changing the net pressure of the fish. Anyway. Let's see. So no Juicy C. I don't know what this guy. Don't explain to Gary. He's just another shitbag Jew from New Jersey. Who's going to be impressed by that? Or even, I mean, as a troll comment, it just doesn't go anywhere at all. I mean, nowhere. Wait, you think I'd find it bothersome to be called a Jew? No. When you do the experiment, you find the graph of this form. Well, I'm bothered to go see that. Do what experiment? When you plot the energy against the frequency, the slope is Planck's constant. Well, again, so you're going to use a constant as evidence of something, and I just think that's bogus. You can't see a photon. I'm quite obviously agreeing that frequency, how often the impacts take place, is energy. So there's no disagreement about that. Who's playing semantics games, douchebag? I'm playing semantics games about something rather important, which is you can't tell velocity by taking big giant hunks of time like 10 meters per second and call that gravity. When obviously gravity doesn't care about a fucking second. Okay, it's applying its force a lot more often than per second. So that's bogus even as a concept.